Okay, in this problem, we want to find the center of mass for the region bounded by y equals x cubed and y equals square root of x. So the first thing that you want to do is let's draw these things out. So the square root of x, it looks like a hook. So it looks something like this. Here is the square root of x. And the x cubed graph kind of looks like spaghetti. Looks kind of like this, going up and then going back down. Okay, so that's kind of what the x cubed graph looks like. And you want to find the center of mass for the region bounded by these graphs. So this guy right here. Okay, now if you know anything about the parent functions, you know that this is just going to be from 0 all the way to 1. Okay, and that's, you can do it by inspection or you can just see it by the parent functions. If you don't know, one way that you can do is just set them equal to each other. X cubed equals square root of x. Square both sides. You're going to get x is equal to x to the power of 6. When I move it over, I'm going to have x to the 6 minus x equals 0. I'll factor out an x. X to the 5th minus 1 is equal to 0. So then I get x equals 0. X to the 5th minus 1 equals 0. Add the 1 over. X to the 5th equals 1. So then when I take the 5th root over, you know that x can only be 1. So here you can see that x equals 1 and x equals 0. Okay, so here is a much more complete way to do it, but you can always just do it by inspection. By inspection, usually when you have the parent functions, it's really easy to tell. Okay, so now once we have that, we have our limits of integration. We want to find our center of mass. So like I said before, the first thing that I'd like to do is find the area first, bounded by these graphs. So let's first find the area. So find area, find A. So the area is just going to be the integral from, I'm just going to write A equals from A to B of f of x minus g of x dx. Now the question here is, what is f of x and what is g of x? Well, it's always going to be the upper function minus the lower function. So you can see that this is going to be, f of x is going to be the top function, which in this case is a square root function. So that's the square root minus g of x, which is a lower function, which is just going to be x cubed dx. Okay, so I can rewrite this as the integral from 0 to 1, x to the 1/2 minus x to the 3rd dx, which is going to give me 2/3 x to the 3/2 minus x to the 4th over 4 from 0 to 1. And then when you evaluate this, you're going to get 5 over 12. Okay, so that's my A. So notice that my A in the previous problem was a 1. In this case, it's 5 over 12. Okay, and now let me find out what x bar is. So x bar is going to be equal to 1 over A, integral from A to B, x f of x dx. Okay? All right, so I'm going to have 1 over 5 over 12, integral from 0 to 1, x, and then f of x. Now notice that we're not going to have just f of x. Now in this case, let me go all the way back up. We're going to have this, oh god, where is it? Here it is. F of x minus g of x. So I actually forgot this g of x. So let me erase this. Minus g of x dx. Okay? So I'm going to have this square root of x minus x cubed dx in there. Okay? So what is this going to give me? So this is going to give me 12 over 5 integral from 0 to 1 of, I'm going to distribute this out. And what I'm going to get is x to the 3/2 minus x to the 4th dx. Then I'm going to have 12 over 5. I'm going to take the integral of that. That's going to give me 2 over 5 x to the 5/2 minus x to the 5th over 5 from 0 to 1. So then I'm going to have 12 over 5, okay, and then I'm going to plug in the 1 in there, and what is that going to give me? 1/5, okay, which in turns gives me 12 over 25. Okay, so that's what x bar is going to be equal to. Okay, so I'm going to do the same thing, but now with y bar. So y bar is going to be equal to 1 over a integral from a to b of 1/2 f of x squared minus g of x squared dx. Okay, so a in this case was still equal to 5 over 12 integral from 0 to 1, 1/2. Then I'm going to plug in f of x. F of x, remember, was the top function, which in this case was square root of x. So I'll have square root of x squared minus the lower function, x cubed squared dx. So I'm going to have 12 over 5 times 1/2 integral from 0 to 1 of, I'm going to have x minus x to the 6th dx. So I'm going to have 12 over 5 times 1/2. This is just going to give me x squared over 2 minus x to the 7th over 7 from 0 to 1. And then when I put all of that together, I did it before, I get 3 over 7. Okay, so my center of mass, x bar, comma y bar, is going to be 12 over 25, and then 3 over 7. Okay, so not nice numbers, but this is basically what you'll have. Okay, now let's finally do this last problem. So set up the integral for a, x bar, and y bar for the region bounded by the triangle with vertices 0, 0, -4, 2, and 0, 6. Okay, so here they didn't give us a function. So they gave us this triangle, which we're going to go ahead and do. Let's go ahead and draw this. So 0, 0, here's my x-axis and my y-axis. 0, 0 is right here. I'm going to label this 0, 0. 0, 6 is up here. Here is 0, 6. And then -4, 2. Here's -4, 2 is around there. Is right there. Okay, so we have this triangle. Okay, -4, 2. And what we want to figure out is the center of mass, or just set up the integral. We're not finding the whole thing, doing the whole thing. We're just setting it up. And for this region that's bounded by this thing. Okay? All right. So the first thing that we got to do is that you can see that there's something above it and something below it. So this graph, this part is the thing that's above it. That's the thing in blue. And the thing in red is going to be the thing that's below it. So you see that you have two different lines that are above and below. So you need to figure out what those functions are first. So how do you do it? Well, one way to do it is to find the equation of the line. So if we find the equation of the line between here, we can have a function. We're going to have a function already, and then find the equation of the line of the red one. So let's look at the blue line. I'm going to write blue. So what are the 2 points? So the 2 points in the blue line are -4, 2 and 0, 6. So let's find the equation of the line. Well, we know the equation of the line is given to us by y minus y1 equals m times x minus x1. So before we do that, let's figure out the slope. So if I say this is x1, y1, x2, y2, then our slope is going to be the following. So it's going to be y2 minus y1 over x2 minus x1. Okay, so what is this going to give me? So y2 is going to be 6 minus y2 is 2. Then x2 is 0 minus x1, which is going to be -4. Okay, so what I'm going to have is 4 over 4, which gives me 1. So the slope is 1. Okay, so now all we got to do is plug it in here. So I have y minus y1, in this case is 2, equals m, which is 1, x minus x1, which gives me -4. So I'm going to have y minus 2 equals x plus 4. I add the 2 over, y equals x plus 6. So this equation is the equation of the top part. I'm going to write it over here. Y equals x plus 6. That's the top blue one. Now what I want to do is find the equation of the line for the red one. Okay, so I'm going to write red. Okay, so that is between these 2 points. Negative 4, 2 comes up again. Negative 4 comma 2. And the next one, which is going to be 0, 0. Okay, so I'm going to find the equation of the line between these 2 points. So again, I'm going to do x1, y1, x2, y2. Okay, so I'm going to have y minus y1 equals m times x minus x1. Okay, so first let's figure out what m is. Y2 minus y1 over x2 minus x1. So let's plug that in. So I'm going to have 0 minus 2 divided by 0 minus negative 4. Okay, and what I'm going to get is negative 1/2. Okay, so now let's plug them in. Y minus, and I think what would be easier would be to just plug in this one, because 0 is much easier to work with than the other one. Y minus 0 equals negative 1/2 x minus 0. So what I'm going to be left with is y equals negative 1/2 x. So my red part is going to be y equals negative 1/2 x. Okay, so notice we haven't done any calculus left. All of this was just algebra 1 stuff. Okay, now let's do the calculus. Okay, so now what we're going to do, let's go ahead and figure out our a. And notice that we're only setting up the integrals. Okay, this just tells us to set it up. Okay, so for a, all we have is the integral. Because we have 2 different curves, notice that we have the top, the blue one minus the red one, we're going to have to use the big formula. A to b f of x minus g of x dx. So this is going to be the integral from what to what? Well, let's see what my x value should be. So my x value should be from negative 4, that's where it starts, all the way to 0. That's where it ends. It's going to be from negative 4 to 0. F of x, in this case, is my top graph. My top graph is the blue one, x plus 6. Minus g of x. That's my bottom graph, which is my red graph, negative 1/2 x. dx. Okay, since we're only setting up the integral, we're just going to leave it as is. Of course, you're more than welcome to do it to practice some integration. So that's a. Now let's figure out what x bar should be. X bar is going to be equal to 1 over a integral from a to b of x f of x minus g of x. Okay, dx. Okay, so now all we got to do is just plug everything in there. So it's going to be 1 over a, whatever a was, integral from negative 4 to 0, x, f of x, which is equal to x plus 6, minus g of x, which is going to be negative 1/2 x dx. Okay, this will be setting up. Okay, y bar. Okay, y bar in this case is going to be equal to 1 over a integral from a to b of 1/2 f of x whole thing squared minus g of x whole thing squared dx. So it's going to be 1 over a integral from negative 4 to 0, 1/2. F of x in this case was x plus 6. I'm going to square that. G of x was negative 1/2 x. I'm going to square that too, dx. That's going to be my y bar. Now, obviously, I did the harder part, but I did the more harder part, which was making the equation, I think. I think this is just really lengthy. But if you really wanted to know what these numbers were, if you want to practice at home or figure them out, what I ended up getting for this guy was 12. For a was equal to 12. For x bar, you end up getting negative 4 over 3. And for y bar, you end up getting 8 over 3. Even though we just wanted to set them up, but this would be the solution if I were to ask you to something like this on the exam, just set them up. If not, then this would just be, this would just be the answers if you want to check, if you want to go ahead and go through all of the messy algebra. So, because you can see here, you're going to FOIL all this out, combine things. It's just a big mess. But this is just the answer. we didn't need to know all of this stuff. We just wanted to figure out what, or just set up the integral itself. But this is how what center of mass problems look like. They're really messy, really long, but that's just basically what it is.